This recording captures one of three presentations delivered on March 31st, 2021 to members and guests of the Waikato Branch of the New Zealand Institute of Primary Industry Management. The aim is to extend the relevant science and understanding of organic soils with farmers, agricultural advisors and rural professionals to support effective management of peat soils.
I'd just like to start with this image. I guess it just illustrates some of the issues we are facing, particularly in the lower catchments. So this is Muggeridges, just south of Ngātea on the Hauraki Plains. And as Justin pointed out, when you get a bit of rainfall, they're facing some issues. And while this might be a relatively extreme example right now, it is a little bit of a picture into where we could be heading in the future as subsidence continues. So I just want to quickly recap, just so we're all on the same page. So subsidence rates are averaging about 2 centimetres per year. We know this varies spatially and temporally. And these lower catchments like the Hauraki could be compounded by sea level rise, and as Justin talked about, there is a threat to adjacent wetlands. And then as Dave's just talked about, we've got quite large greenhouse gas emissions. And those numbers are there, that I've got there, are from both the sites. So there was one that was lower and one that was higher, and Dave presented an average number of, I think it was 21. And if you calculate just for the Waikato region, that could be something like 20 to 25% of the region's agricultural greenhouse gas emissions. So it does suggest we might need to look at doing something. Interesting things to think about is going forward, what's the threat as far as global market access? And I'm going to talk about that a bit later, what's going on overseas. And those numbers that Dave threw up recently, what if farmers had to start paying for this? It could take quite a hit on their profit, and it would really threaten land use on peat soils. And if you put that together with increased pumping costs, you're really starting to get into a little bit of a sticky situation in some places. So really, this talk's going to focus on what can we do. And I'm going to do this in two parts. So the first part's going to look at the potential for improved management practices on current land use. The second part will then focus on potentially what we could look at as more transformational change. And when I'm talking about transformational change, I'm not saying we're going to have to do more changing land use everywhere. I'm just saying there's likely to be areas where we're really going to run into problems. So, recognising this issue, the Regional Council recently commissioned us to do a bit of review of international literature. So what's being done overseas, what's being trialled overseas, recognising that it might not be directly transferable to the Waikato or to New Zealand, but what's the starting point, what are things we could look at? And so we did that, and we came out with a few recommendations at the end. I'm just going to run through all these things that we've sort of looked into a little bit now. I'll have to go through it pretty briefly, there's quite a bit of stuff to cover. But obviously water table management is somewhere we want to start. I mean, essentially soil saturation is the overriding control on subsidence processes. And if we look at the international literature, it's very clear that there's strong relationships between depth to the water table and subsidence rates. And there's a lot of literature out there, but this was sort of a synthesis, if you like, where they've looked at subsidence rates and water table depths, different places around the world. And it was clear that as the depth of the water table increased, subsidence rates increased, but there is a difference between, for example, the Netherlands there, lower down, so cooler, but also being drained for a lot longer, and potentially tropical peatlands where subsidence rates are a fair bit higher. And while water table management makes a lot of sense, we've got quite a few questions as to, is it really that easy? As Dave pointed out, the evaporative water loss is a large component of the water loss. So if you block up drains, say in spring, to hold water back, that's going to help you to some extent, but it might not be a heap when you've got that other big water loss. And even if you're able to bring water in and just top up the drains essentially, the lateral influence of those drains on the paddock is also going to be could be relatively minimal, because of the hydraulic conductivity of the peat and the high evaporation rates that you're dealing with, you might just get a fairly localised increase in the water table around the drain. And obviously you need a large source of water, so where's that going to come from? And if you're thinking about higher up in the Hilton Basin, so Rukahia, Monotouatua peatlands, there's not a lot of extra water around to use. Lower down they might have some options. And then there's also trafficability, so there's issues if you bring the water table up too much of having cows on soft soils, as Dave mentioned. It's not something we want to do. So while at first glance we think water tables, let's bring them up, we need to be thinking about that pretty carefully. Now, what I'm going to do just as I run through these, I'm just going to flick this up towards the end of it, and it's just essentially a measure of impact. So do we think this could help peatland subsidence? And if there's evidence from the international literature that suggests that it could be up to, say, 50% reduction in subsidence or reduction in greenhouse carbon emissions, then I'll give it sort of four stars, somewhere like that. But is it also feasible? When I'm saying, well, here, if we could bring up water tables, I think the impact could be quite significant. But the feasibility, and I've probably been quite optimistic there, how feasible is it? And this is sort of working on 5 stars. So one of the other things that is being trialled overseas quite a bit is subsurface irrigation. And what this does is it gives you finer control on the water table across the paddock. And so we can see in that top image there is a sort of business as usual. So during winter you get quite high water tables. During summer you've got low water tables. You put the irrigation pipe in, essentially submerged drains that also function for irrigation, water input underneath, and it just allows you to manage that water table a lot better. And there are clearly co-benefits to this. So by keeping that winter water table down, you can improve trafficability, probably improve pasture production by not having so saturated, and during summer you can keep that water table up a bit, which should improve pasture production. So there is some benefits to this. Interestingly, there's quite a few studies that have looked at this, and the findings are not really consistent. So some earlier work in the Netherlands suggested that you could get something like a 50% reduction in subsidence rates and CO2 emissions by using this type of approach. Some more recent work that's come out of the Peatwise project in the Netherlands, which Dave brought up very early on in his presentation, suggests that these irrigation pipes have a very localised influence on the peat soil moisture content. It might only be a metre away from the pipe. And they also found that summer CO2 emissions increased. So it's probably not a silver bullet, there could be something in it. But again, water source is problematic. So where are you going to get the water from, especially higher up in the catchments? So I'm going to say, because we've seen that findings are not consistent, we can't really give that a 5-star impact, but I mean it could have potential. Feasibility, questionable. Another option is that this was just not a field scale experiment. They just collected columns of soil essentially, was looking at the frequent flooding. So flood the land frequently and look at the effect on subsidence and CO2 emissions. And they compared constantly flooded to 10 day, flooding every 10 days, flooding every 25 days and flooding every 50 days. And while the results looked fairly promising from this work, so you can see flooding frequency on the x-axis, on the lower figure, subsidence on the y-axis, and CO2 emissions, and going from constantly flooded on the left through to constantly drained on the right. So it does suggest that this has quite a good influence on both problems. But again, we've got issues around water supply. Where are we going to get this water to flood frequently? And in a pastoral situation, doesn't really make a whole lot of sense flooding in pasture frequently as far as productivity from pastures go. So I'm going to say with this one, potentially quite a high impact, but the reality, practicality, feasibility, pretty low. And then another one that sort of comes up, there's very little literature really to support this, but looking at different crop types and what could be the benefit there. And some of the early carbon balance work Dave did in peatlands around the Waikato showed that the carbon balance of the system was really strongly influenced by pasture production, and sites where the water table was higher had similar total respiration, but the pasture production increased the carbon balance essentially, so you lost less carbon from the system. Other things we sort of thought about, can we identify pasture species that tolerate higher water tables? There could be something in that, but very little literature on that. And thinking about that evaporation as a really large component of the water balance, as I said earlier, could we restrict evaporation with crop type? So thinking about high water sufficiency in pastoral systems. And again, there's been very little done on this, but I mean, we could maybe consider things like C4 grasses. And so, jury's a bit out on the impact, but there could be something in these. I think feasibility-wise, maybe we could be looking at something like practically it could be a solution. And then cultivation. So obviously, cultivation increases oxidation of the peat, which increases subsidence rates and CO2 emissions. And as Justin pointed out, there was some early New Zealand work which suggested that subsidence rates were at least twice as high under cultivation compared to continual pasture. And international research supports this. So there's been quite a number of relatively good studies done around this, and this is some work from Sweden where they looked at cropping intensity, so row crops being the highest intensity, and we could equate that to maize production, continuous maize production on peat, through to managed grasslands, which the subsidence rate was less than half of that under row crops, and also carbon loss was less than half. So we would say avoid cultivation if possible, but we do recognise that there is a need for incorporation of lime, pasture renewal and those sort of things. So here we're going to say impact could be quite high, feasibility, we probably can do something here. Another one that comes up in the international literature is nutrient input. So clearly bogs are a low nutrient environment, we drain them, we need to bring a lot of nutrients in to grow pasture. And when you're doing that, you bring a fair bit of nitrogen and phosphorus into the system, and this promotes decomposition and so therefore subsidence and CO2 emissions. We couldn't find in the international literature a whole lot that's been done in this area. There was this one study that looked at the carbon to nitrogen ratio, which is what's shown on the x-axis there, at a range of different moisture contents for each carbon to nitrogen ratio versus the CO2 loss emissions from the system. And it does show that as that carbon to nitrogen ratio narrows, so you've got more nitrogen in the system, the emissions increase. Again, I mean, we could say minimise nutrient input is likely to reduce CO2 emissions, but again, we've got implications for production. So trade-offs here for sure. So could have an impact, feasibility. I mean, it depends how we're managing our nutrients, but we want to manage our nutrient budgets carefully. But if you're already doing that, you might not have a whole lot further you can go. There's also been quite a bit of work done globally on surface amendments. Surprising amount actually. So in the Netherlands they've played around quite a bit with clay cover, and The data I'm putting here obviously just shows the ditch water level along the x-axis of subsidence rate on the y-axis. The black squares there are for areas that have got a clay layer greater than 40 centimetres thick versus the blue diamonds which have no overlaying clay layer. And while the data is relatively messy, it does suggest there could be something in it, but I have in some ways cherry-picked the literature because there's definitely studies which show no effect, and also studies that show for deeper peats it may increase subsidence rates. So jury's definitely out on that. Another one that's been looked at is sand, incorporation of sand in the surface. From what I can see, makes very little difference to subsidence and CO2 emissions. The only benefit would be maybe an increase in trafficability. So if you want to bring your water table up, you might be able to use the surface a little bit more robust. And then organic amendments. There hasn't been a heap done in peatlands looking at this, but because of the numbers, the emissions from peat soils, you'd have to bring a heap of organic matter in to make any difference. And you'd really want to grow it within the farm system, because if you're importing it from somewhere else, there's probably negative consequences associated with that. So surface amendments, I'm going to say probably not much in it, and feasibility, you probably wouldn't want to be trucking in truckloads of clay and truckloads of organic matter into these peatland systems. So also need to be aware of factors independent of management that control subsidence rates. And Justin touched on this as well. So this was from some work I did a few years ago in the Waikato region, and also pulling together rates of subsidence versus time since drainage from global literature for temperate peatlands, and clearly showed exponential decline in the subsidence rate with time. But it does flatten out lower on that curve. It's sort of 10 to 20 millimetres a year, so that's about where we're at in the Waikato at the moment. Also, organic matter content, peat depth. So we typically see higher subsidence rates and CO2 emissions with higher organic matter content, higher subsidence rates with deeper peats. And there's also weather and climate factors. So when you get dry years, you tend to get very high subsidence rates, and you can also get quite high CO2 emissions. So this is just really a bit of a quick summary, and I'd almost love to talk through each of the star ratings with you all, because it'd be really nice to get your feedback on what you think the impact and the feasibility of some of these things are. Could be useful for us going forward. But I guess the take-home message is there's a couple of things there that might reduce subsidence and CO2 emissions by, say, 50%. It's still going to be ongoing, so there is no silver bullet in there. Subsidence and CO2 emissions are going to continue, but what else could we consider? So if you've got any ideas, write them down those bits of paper and fire them through, and I'd love to talk to you about it. So out of this review, and I just want to point out again that this was international literature. We don't know how relevant a lot of these studies are to the New Zealand situation. New Zealand peatlands are quite different. So there's a few things we want to do. And the first thing we recognise is we really want to develop some sort of a vulnerability index. So look at where the biggest problems are going to occur first, and this is probably angling at the hierarchy, the lower peatlands, where drainage is becoming an issue, and what sort of management practices should we test. And so this vulnerability index would inform what we might look at first. Once we've done both of those things, we'd want to develop a catchment scale management decision support tool so that brings all that together and just provides advice. So a farmer can look at what his situation is and what he could use. And we also want to think about, is there any need to develop policy incentives to support implementation? So I'm going to change gears here now and look at the argument for transformational change, which is really talking about land use change, recognising that there is stuff we can do to improve the current situation, but if you're looking long term, we probably need to be looking at what all the options are. So alternative land uses, including re-wetting, may be required in the future to align with government strategies and policy, international climate agreements, and I think one of the big ones that we may, or some people definitely recognise, but might not be taken into consideration, is the sort of global market pressures that are going to come on, or could come on in the future. And we're seeing some signals internationally at the moment we probably should be thinking about, and I'll go into that a little bit later on. And also the consequences of delayed action. So obviously you leave it another 50 years, the Hauraki's another metre down, below sea level, you've locked in the costs of long-term pumping. So if you decide to stop pumping that land, then you're just letting the sea in, basically. So you want to think about that. There's the consequences of ongoing peat oxidation. So that peatland has still got a very high amount of carbon stored in it. And incidentally, I think if you do the numbers, it comes out at, I think it was about, over 50 years, about $40,000 worth of CO2 emissions at the current cost for a tonne of CO2. And again, what are the consequences of delayed action on international market access? So I just want to look quickly at the consequences for delayed action. So this was a recent study from Nature Communications where they modelled the radiative forcing of re-wetting peatlands now or very soon versus doing it later. And the issue here is that CO2 is a weak but persistent greenhouse gas. So the sooner you stop those large CO2 emissions, the better. You're creating a methane source, but it is strong but short-lived gas. So the plot on the left shows the overall influence of re-wetting earlier versus re-wetting later, and then they've got the warming effect on the right-hand side. So we definitely want to keep that in mind if that was an option. And there's other things going on, for example, the United Nations FAO Global Priorities for Peatlands. And there's some good stuff there, understand distribution, improve greenhouse gas accounts, intact peatlands conserved. But let's just point this one out. True cost of peatland products accounted for. And that's definitely a threat to global markets going forward, I think. And then we've got signals from Nestle. So they've got a zero roadmap, December 2020. And they want to reduce carbon emissions to the atmosphere by 13 million tonnes by 2030. And one of the ways they are proposing to do this is restoration of forests and peatlands. So if we start looking internationally, what's going on? Is this sort of thing happening? So there's quite a lot of, I guess, pilot activities to some extent, looking at polluter culture. So haven't really talked about polluter culture yet, but so that's essentially flooded agriculture. So it's still getting an income off the land. I think markets are still in development for a lot of this type of stuff, so there's work to be done here. It's not the silver bullet either. But I've just listed a whole lot of things down the side here that they are using polluter culture products for. And I think as markets develop, there is options here. And I mean, one of them that comes up if you're into beef production is water buffalo. So it's just lower stocking rates, higher water tables. And if we zoom in on one of the examples here, so this is in Germany, a province of Germany which accounts for, it looks like 9% of the total peatland area, and they've already re-wetted for agriculture, so this will be polluter culture presumably, 7,500 hectares, and then they've re-wetted another 18,500 hectares with no agricultural use. So I'm assuming that's restoration type activity. There wasn't a whole lot of extra detail with that. And then the UK has the UK peatland strategy, and there's a number of milestones in there. But by 2020, peatland carbon is incorporated into the UK greenhouse gas inventory. Peatland management forms part of climate change mitigation plans. And by 2030, all peatlands under sustainable management, as indicated by the Committee on Climate Change. And they had this map in there which just showed all the peatland restoration projects that are going on across the UK. So there is a fair bit of action there. So I'm just going to change gears again a little bit and just make an argument for a bit of a unique New Zealand carbon sequestration opportunity. So, and I'm not saying this is our only option, but this is something we probably could be thinking about. So, as has been pointed out already, this is the natural peatland vegetation in the Waikato, the restiads. So we have the big cane rush and the little wire rush, which is a smaller wire rush, which is the more dominant peat former. And this is a fairly unique vegetation, constrains water loss. We've got peatlands existing in climatic environments where they would not normally because of the ability to constrain water loss. They're also relatively high as far as their carbon sequestration potential. Jordan Goodrich's work suggested that the carbon sequestration could be around 8 tonnes of CO2 per hectare per year. So that's quite large for a peatland environment. Also thinking peatlands have a higher carbon density than any other ecosystem. So cover 3% of the globe, store about 30% of the soil carbon store. Continued carbon accumulation over thousands of years, so that's a little bit different to a forest which flattens off after, depending on what sort of vegetation you're talking about, 50, 100 years. These can just keep accumulating carbon, so there's some real strengths there. And you get quite a range of aligned co-benefits, which at the moment we might not be getting paid for as such, but it could be in the future. So, in addition to your carbon sequestration, you've got biodiversity enhancement, freshwater enhancement, those type of things. So, and I guess I just want to make it clear here that I'm not just talking about necessarily peatlands, but historically about 10% of New Zealand was covered in wetlands. And a peatland is a subset of that, but it does suggest that there's a lot of areas in New Zealand with potential to support peatlands or wetland environments that can accumulate carbon and store it. So there's the opportunity for reconstruction, and there'll be areas where we should be looking at that, and areas where it just doesn't make sense. If you've haven't got the water available, and so I'm thinking about the higher peatland. Higher in the catchment, Rotoruka here, it's going to be very difficult to do something like this. So, but it's not an option everywhere, but there's absolutely areas where it would work. And then there's looking at reconstruction of peatlands on areas which currently have no peat, may have in the past, but there's a lot of areas on farms now, valleys and hill country, and also these sort of areas which are being fenced off, and there may be some potential. So I guess I'm just going to flick now to sort of what the vision is of something like this would be. Essentially farmers get economic benefit for the carbon storage, so what they'd be doing is retiring areas of their farm that are not productive. So you'd focus on your productive areas for production. Areas of your farm will be potentially suitable for something like this. Co-benefits could be used by industry to help derive value from products. Potentially, if we're looking at polluter culture, could ultimately provide a diversified income for New Zealand. And there's still a lot of homework to be done there. And ultimately, we could slash New Zealand's greenhouse gas emissions. And I just want to be clear, this is not the only option, this is just one option we could be looking at, or out long term. Finally, I just want to talk about funding opportunities. So there's a whole lot of stuff we've talked about here, ranging from tweaking current management practices to improve the situation through to quite transformational change. And I really just want to put the options in front of you and show you some of the international signals that are coming that might give us an indication that maybe we should be thinking about some of these things. So, Waikato Regional Council has their long-term plan, and I mean that's really more focused on the management. So looking at vulnerability assessment I talked about earlier, and looking at what management practices we might bring in. There's other funding mechanisms, for example, the Sustainable Food and Fibres Futures. That could be something where we look at polluter. This does require significant industry co-funding, and so there'd have to be quite an interest to help get something like that over the line. Incidentally, there are quite a lot of Māori groups who are quite interested in polluter and digging into that at the moment. And then there's the MB Endeavour, so Ministry of Business, Innovation and Employment. And this is focused on more transformational change. Has a very high bar for science excellence and impact, but that's the sort of way we'd be heading if we were thinking about the more transformational options. And obviously, these days, co-development is critical for research funding success. So if we're going to be able to test any of these methods, look at what the options are in the future, we need to be co-developing our proposals. And so this is to ensure a two-way transfer of knowledge, ensure that outcomes provide practical pathways for end users, ensure alignment with Māori aspirations, and inform and engage with regional and national policy information. So, interested in your feedback and the opportunity for co-development. Thanks for your attention. Contact details.